So I'm John Lyon-Smith, VP of Engineering at a company called Brown Paper Tickets here in Seattle. I don't know if you've heard of us. We're kind of like Eventbrite or Ticketmaster, only we're not evil. And if you have an event and you want to host an event, we do free ticketing for free events. And we have the lowest rate in the industry if you're a ticketed event for credit card processing and stuff. So anyway, little plug from my company. We're also rewriting our entire app in React and React Native. So we're getting lots of war stories. So I'll probably come and share those with you as we progress. So I had a quick question for Zoe. Who in this room is a React developer? Okay, and who? Keep your hands up. Keep your hands up. So who is also writing a mobile app? Okay, there's like one for two people. And who's using React Native to do that? Okay, so some different people. Okay, cool. And who's doing a native app with AR or VR? Okay. Well, here's your chance to see that it's actually not that hard to add some AR or VR to your application. And I think that I was asked the other day what I think the top technologies upcoming technologies are for the software industry, and I think in order it was AI. I think then VR and AR are probably the next the two big things. Oh, and robotics is probably in there too. So, but I think you're going to find you're going to get asked to do this stuff at some point in your careers. So the star of the show here, and pretty much the only game in town when it comes to doing AR and VR right now across Android and iOS without having to basically do separate implementations on each platform, is a product called Viro AR. So or Viro React is the actual name of the React component. And so a lot of this talk is going to be about that Viro component and my experiences using it earlier this year on a project. So basically, Viro is a way to expose the underlying built-in functionality of your phone. So on iOS, it's ARKit and the Metal and the other 3D rendering technologies. And on Android, it's ARKit and the OpenGL rendering platform. So basically, it provides layers on top of that expose that functionality, but you're going to be limited by what that functionality is. And right now, there's only a couple of differences between the two. Android's playing catch up a little bit with Apple. So you can do VR, and you know, I am going to focus on the AR stuff today because it's because it's more interesting to demo. Basically, I have a VR headset here, so what we could do is just pass this around, but I don't think that's going to work very well. So starting here, actually, this is yeah, if you guys want to look at it, this is actually a trick VR headset. It's actually a Daydream, Google Daydream, but you're welcome to look at it and take a peek. There's nothing in it. Basically, the idea is that you take your high-end phone and you plop it in the front of it, and basically you run a VR app on it, and it actually works pretty well. If anyone's used an Oculus, that's also pretty impressive, and I'll actually probably do another talk specifically on VR stuff because it's actually kind of cool. There's a lot of stuff going on now. But right now we're going to focus on AR. So the cool thing about the Viro AR, or actually Viro AR and what it exposes is, the first thing it exposes is this thing called surface detection. When you're dealing with AR, it's all about detection of surfaces and interesting locations in the real world. So the idea, has anyone ever played with an AR application? Yeah, good. So you kind of know what I'm talking about. You hold your phone up or your iPad or whatever, and you see essentially a video or an image of the real world, moving image, and all of a sudden stuff pops up on that image, and it's actually integrated into that image. To do that, you need something called surface and feature detection. So surfaces being like the surface of this table, that wall, the corner of that TV screen over there. Those are interesting surfaces, and there's some serious magical mathematics going on inside your phone to make that happen. So be impressed whenever you use it, because it's pretty cool stuff. Okay, so that would be cool in itself, but what you add on top of this is you add real-world 3D tracking. So you see when I do the demo, It's not enough just to detect the surface of, say, the table. If you put something on that surface in a certain location, you want it to stay there as you move around so that it feels like it's really in the real world. And that's part of the illusion of AR. And that is another whole nother problem of how you make that work. But again, it's something that's built into your phone. The next thing is you've got this place in the real world and you want to put something on it. Well, it needs to be rendered and basically it needs to look good in the real world. One of the really hard problems actually you'll find is that putting something in the real world is fine, but if it doesn't look like it fits there, it will seem cartoonish and not good. So part of the trick is going to be, as we all get better at doing this kind of stuff, is actually getting the lighting correct and getting the surface texturing and stuff and making it look like it fits into the real world. And that's actually something that the AR toolkits again can help you. They can tell you which direction the light's coming from, for example. Again, this is some really cool magic. And then we won't talk about this today, but actually I was thinking this is a fun talk for another time. There's new stuff coming in now, market detection. So I think QR codes in the supermarket, right? But instead of having to actually scan the thing, your phone could detect a QR code on something across the room and immediately detect that that's an interesting surface, and you can put something on that surface. And then finally, real-world effects. This is something that's just starting to really get in, but you'll see like fire effects, rain effects, fog effects, stuff like that. So I've seen AR apps where they put like a fire in the middle of the table, and it looks really photorealistic. It's amazing. And all, on a device that you have in your pocket, which is pretty cool. So, okay, so I'm going to go quickly here because I don't have a lot of time, I know. So why is ViroReact really great? Well, basically, I think the documentation is excellent, which is always a key thing as a developer. I look for decent documentation. It's free, and I don't know why it's free, because it's really quite impressive, and I would actually pay for it. But it is free. They have great support. They have a Slack channel, and earlier this year when I was using it, ARCore was in beta, and the ViroReact guys were trying to releasing updates as quickly as Android kept releasing updates, and so they were really responsive in dealing with that. So that was really cool. And it's easy to get a license key. A lot of companies will make you jump through hoops, like Google. I'm looking at you. Just have to do all sorts of silly things to get a license key that works. Not with these guys. I just mail it to you. Just give them your email. Okay. So let me talk about this app that I'm going to demo to you today. So earlier this year. Basically, there's a company up in Toronto called Dayton. They do public services, trash cans, like replacing street lamps, stuff like that. And my good friend, they wanted an app written. My good friend Steve Eros, who's in the back there, waving his hands, who is a consultant, runs a consulting company down in Seattle called Facet Development. Amazing company, really great guy. If you need developers, he's your man. If you are a developer and you want to do some moonlighting, you go talk to Steve. If you're awesome, he'll give you money. So, my company, my little consulting company, Kingston Software Solutions, we basically did this project to help with Facet Development. So, what's the app? Okay, so the app, as you'll see, I'm just explaining this so you understand, so it makes sense when I show you the demo. The goal is you place work items on a map. So this is meant to be a training application for Dayton. They wanted to be able to send people out around town to find sort of fake work items and basically click on answer a questionnaire when they got there and basically fix the problem. And then it was essentially, it's like Pokemon Go, I think in that sense. And then once they get to the item, they mark it as done, take a picture, upload a photograph. And the first team, they do it in teams, and the first team to find all the work items wins. So that is the app. So I'm going to do a demo quickly, hopefully it will work. And then we're going to talk about code. So 1 second. Get this. Okay, so I think if I move this way, it pops onto your screen. Good. Okay. So hopefully, sometimes I have problems with this cutting out. So my apologies. So now I'm actually running this app on my phone. So you see there's a map here, Google Maps, and there's lots and lots of little pins on it. One of those pins I put there earlier. That's actually a work item right here at Microsoft, Building 20. So I'm just zooming into that. So the idea is that we're here, we get ourselves close to the item, and then we can click on this little button in the top right-hand corner. That's up here, this little goggles up here. Click on that, and now if I stand still, move my phone around. There you go. So there's a hard hat now in the middle of the room, right here. So look at what's interesting about this hard hat, right? So it's holding still while I'm bouncing around. So I can walk over here. We can go. It's still in the same spot. I can duck down. Look, it's got a little shadow underneath it. The shadow's in the wrong spot because I think the surface detection didn't quite get the ground, but. And there's several different shapes and sizes. You can see it's got some lighting on it. It's not a very detailed model, so that's why you can see all the different surfaces. But if you had a better rendered model, you get more photorealistic. So that's basically augmented reality right there. So the idea is you can click on this. We can go into that work item. We can take a picture and basically do something there. So if you guys upload it. The app. So that's the app basically right there. So you can see how the app isn't about AR. It's just something that's enhancing the functionality of the app. The app is actually a training app or a Pokemon Go like app really, but it's got nothing. It's not really but the AR enhances the experience. Okay, so I'm going to slideshow. So how does that work? And how can you do that in your apps? Okay. You guys still hear me? Is this still working?
Yeah.
Okay, so let's look at some code, because I know you're developers and you all like to look at code, right? Just be grateful that I'm not going to type it all in, because I just really hate those demos where you're waiting for somebody to type and keeps backspacing. Anyway, so I'm just going to do a couple slides here just to give you kind of a feel of how the difficulty level of this, so you can go back to your teams and say, hey, I saw this really cool talk and it's only like 3 slides worth of code, 4 slides worth of code. Well, there's a little bit more to it than that, but this really is the basics of how you get this into the product. So you go to Viro, you get a license key, you download the NPM module. Again, we're talking about React Native here, so it's the same basic idea with React Native as it is with React. You download an NPM module, and there's also a native component that you have to install as well into Xcode or to Android Studio, whichever one you're using. But once you've kind of got that, we could do a whole talk just on the nightmare that is building apps for production for iOS or Android. They each have their own little want to stab yourself in the eye type of moments. But once you get into the JavaScript part, it's a piece of cake and it's really fun. So there's kind of this weird love-hate with React Native. It's like, I'm loving my life here, and then you go and you have to deal with like Xcode, and you're like, oh, I want to kill myself. So anyway, so the first thing you do is you bring in a bunch of different components. Not very exciting, but that's basically the way you start. And then somewhere out there on your hard drive, you have some models, some 3D models that were created. Now that hard hat, and I can show you later, I downloaded it off a site. Basically, I didn't build it, and I didn't get a graphic artist to do it. Somebody else did it, and I bought it. I paid like a couple bucks, I think, to download that model. So you get what you pay for. It's basically good enough for what I needed. So, and there's some other ones. There's a clipboard, and then some other different ones that I got. So you can see I just load the models. I just do a require, bring them to the OBJ files in. I won't go into file formats, into 3D modeling file formats, but the OBJ format's pretty standard. All various tools can do it. So we load our models into an array. The MTL file is a materials file, so that's how the different thing, you can get a woody color, or a plastic sheen on a hard hat, whatever. So the next thing you do, and this is actually where we get into the meat of the coding, is the way that you get Viro into your application is you create this Viro scene. You mount this Viro scene navigator component, and that's kind of like the root of your Viro of your AR VR component. And you can basically just, as I'm doing right here, you just mount that into a React Native view, which is similar to it. It's just a div in it's the div in React Native, basically, there's a few weirdnesses here. You give it the API key, obviously. You set the initial scene. So this is essentially like a stack of scenes. You can create like a whole hierarchy of different scenes with different models and things in it if you want to. I'm just using it in a one-to-one mode here, where there's one navigator, one scene, and that's perfectly fine. It doesn't take a long time to load and initialize. It's pretty fast. And then in this case, you can see I'm just passing in some properties. There's a little bit of a different way you have to pass properties into it, but it's pretty straightforward. Just pass a dictionary in with the useful stuff that you need. In this case, the work item, type of work item. And this is the last slide of code I'll show you. So this is probably the whole talk right here in this one slide. So I don't know if you can see this, or if it's. Hope I tried to make it as big as possible, but. And I'll give you a link to the slides and the sample code that I have that accompanies this talk, so you can actually go look at it and try it out if you want to. So basically, you create so this is the actual body of the render method in the React component that was the work item scene AR. So this is actually what's in the render method. So we're rendering a scene object, and we're telling it that we only care about horizontal planes, so we're going to care about flat surfaces. We're setting some ambient light, because it's like turning on a light switch in a room. If you don't have any light at all, you can't see anything. It's just black, so that's really important to do. Pretty much have to do that all the time. And then the Viro node is the actual 3D model piece, and that has several attributes to it. The first is the spotlight. We're actually illuminating this. It's actually using a 3D coordinate system, which is John's left-hand rule. It's like that way. Basically, no, that way. That's it. Basically, the negative is actually the opposite way. The negative z-axis is that way. It's out in front of you. But everything else makes sense. I always get z order is always the one thing in 3D modeling. You always have to just read the instructions and say which way did you pick, Microsoft or Viro or whatever. So they're all different. So. But anyway, so you set the spotlight, and we're setting it up in the air and basically pointing it down at the object. So that's the spotlight element or component there. And then the 3D object, so the conditional part here, this bit here needs a bit of explanation. So in order to render the model, what we need is a shape loaded into memory. Remember, this is React, so things are happening in a deferred, lazy way, so the shape might not be initialized yet. So when the first render happens, there might not be anything to render, so you have to wait for that. The second thing is the tracking initialize. So the AR system, as you saw when I was holding my phone up, it takes a little while to figure out what's there, what's around you. It takes a lot of processing going on. So that has to happen. And then once that's happened, all the surfaces don't appear immediately. They sort of come in over time, so it kind of builds up a better model of what it's looking at, and they change as well. So you're constantly getting a stream, but there's sort of a critical point where you have enough information to be able to at least take a stab at, that's the floor down there. And I'm actually looking for a flat surface that is about a meter down and about within 5 meters away. So I'm doing the calculations elsewhere in the code to figure that out. That's probably the hardest piece of the whole thing. You have to actually know a little bit of 3D geometry and algebra, so some matrix fiddly bits. So, but yeah, it's not that hard. So the last piece. So once that's in place, so once those things are there, we can actually put the 3D object in place, and you can see that's just loading the resources, setting the scale, and setting the type of the resource that we're loading. The Viro quad is, I don't know if you saw when I ducked down, there was actually a shadow kind of just underneath the surface of the hat. Or basically, the way that works is you put essentially a shadow surface underneath the object. You actually have to put a plane there, otherwise the shadow's got nothing to reflect off of. That's just the way that the 3D modeling stuff tends to work. And that's it. So that's the whole complex difficulty of the code. So I don't know if any of you have ever done 3D stuff before, ever written a game or something, but there's a lot of stuff that typically you have to do, and this is like by far the smallest amount of code I've ever had to write to actually get something in 3D. Obviously, we're just loading a model and showing it, displaying it, so all the work of creating the artwork is something that somebody else always had to wrestle with. So that's basically the talk. How am I doing for time? Do we have enough time to just show you a couple of quick... are you guys interested in any more? Do you want to see, like, I can show you? Okay, cool. All right. Okay, so what about the art, which is the bit that I think is really the key thing. So the cool thing about this, and I think this is actually one of the big enablers of us being able to do this, because we're all developers, and I don't know, there's probably some artists out there, but I can't do 3D modeling. It's quite involved. But there's some really cool tools out there for doing it that don't cost you a penny. One of them is called Blender, and I actually think Blender takes I think should win the prize for probably the most complex open source project that there's ever been. It's open, so it's open source, it's massive, and it's got so many features, but it's really, really hard to get into. It's very different from any other user interface paradigm, but you can do enough to be dangerous. And basically, I can give you a quick demo of that. I'll show you what Blender looks like and how you can load a model in there and generate an OBJ file. The other thing that's really cool is this thing called Cycle. There's about 20 of these sites. I use one called TurboSquid, which is based down in New Orleans. They're basically a site where you can go up and say, I want a picture of a hard hat, and they'll give you like 100 renderings of hard hats, and you can just download the file and again pay a few bucks. I can quickly show you Blender, what it looks like. This is on your screens. Is that showing up on your screens? Cool. That's Blender. I'm going to have to go over here so I can do stuff with it. Basically, where is it? Open recent. There it is. Okay. Basically, there's the hard hat, right? So that's the hard hat that I was rendering in Blender. So again, I'm Blender challenged. So, but the reason I show you this is there is tooling out there that you can get a model, you can change the color, you can change the texture, you actually have enough tooling out there that's free to be able to do this, which is cool. And then there's like really high-end Maya and stuff like that, which are really high-end tools. And if you've got somebody who's got a Maya license, then go for it. But anyway, that's Blender. And then the one other thing I'll just show you quickly is TurboSquid. So this. There's TurboSquid. Basically, I just typed in hard hat, and these are all 3D models that you can download and buy, and they're not very expensive. So there's the hat we're using. You can see they actually did a lot more work in rendering. You can actually crank up the rendering quality, and it slows things down, but you can get a real photorealistic look there. I've actually rendered things in a very non-photorealistic way. And you can actually control that with Viro as well. Viro has some functionality to do that. So, but yeah, you can see there's like 3D models of just about everything. I mean, that's just hard hats, but you can imagine how much stuff there is for something that's actually interesting, dragons or something. So that's TurboSquid. Okay, so I'll just finish off with a couple of extra notes that things that were interesting about this project. One pain when you're doing any kind of AR and VR actually is that they tend to not work in the simulators because in particular AR needs access to a camera and that's not in the simulator. You can do VR stuff in the simulator, but they're so slow that you typically don't like. And also with this, the way that VR works is you typically need to use a weird projection to get the 3D effect. You'll actually see if you run, if you try, I can show you afterwards if anyone wants to see a VR app running on the Daydream. If you pull the phone away and look at it, it actually looks like two round circles and everything's all distorted like a goldfish bowl, and that's how that's how things have to be rendered so that when they go through the weird fish bowl lenses, they actually look normal to you. So anyway, simulators don't work. Building mobile apps with whether it's React Native or Iconic or any of those, it's way too hard to ship stuff. I really hope that Apple and Google fix this one day, but so far, signs are not good that they will. If you've ever built an app with used Cocoa Pods on Apple, then one thing to note is that the use frameworks flag is supported or not supported in Viro, so you can use you can use it or not use it, and that's one of the big issues that we hit early on in this project. And the one big piece of advice I would give you is do not upgrade too soon. Like wait until when you're using a project like this where we had Viro, Google Maps, some navigation components, React Native itself. If you upgrade and one of the other components isn't ready, you are toast. And it is really hard to unupgrade. Trust me, you have to pretty much blow everything away, kind of clean your system out and start again. So just be really careful that everything's going to support that. And but I think that's a common problem. But it's kind of exacerbated in this world because it's so new. Like I said, ARCore was in beta when I first started using it, so it's less than a year old. Another interesting quick thing to notice about this particular app is that we were trying to use geocode, geolocation, and AR in the same app. And if you know anything about geolocation, it has a resolution of about 10 meters, on a medium day. AR is, let's say, 10 centimeters accuracy. I mean, it's pretty accurate. It's actually more accurate than that, but let's say 10 centimeters. So you're looking at a difference of about 100 times, of basically scale factor. So it's really hard. It's actually not possible, and people ask you this all the time. They're like, "Oh, I want to walk into that room over there and go to the 5th table from the left and put something on that table." And it's like, it just doesn't work. There's nothing that can do that right now, except for the marker functionality, which I talked about at the beginning. So if you put like a QR code or something on that table, then you can detect it and put something there. So it's actually I think that's probably one of the big problems why this hasn't taken off quite so much, because that's what everyone wants to do. They want to put like a fake street sign up or something, and put directions and stuff. You can get it to work when your GPS accuracy is really good, and it kind of feels like it's working, but it's actually it's smoke and mirrors. Interestingly enough, I think the solution to this problem is going to be a combination of artificial intelligence and the marker technology. The marker technology is a stopgap. I actually think that AI will allow us to take pictures of a thing that you're interested in, like that table, and take 20 pictures from different angles, upload it to an AI server, and it will then figure out how to generate some code that will tell you if you're looking at that table or not. That sounds completely crazy, I know, but believe me, if you come to me afterwards, I'll show you a site where you can actually do that, and I can upload 20 pictures of your face, and it will recognize you almost with 100% accuracy. So that is actually a thing you can do today. So that's probably going to bridge the divide there. And that is all I have. So basically, if you want more information, I have created a GitHub repo. Feel free that the slides are up there. The slides are fully hyperlinked, so every icon, everything has a link to the resource in there. You can send me a message through GitHub, or I'll give you my email or card or whatever afterwards. And I'd love to hear about the things that you do and next time we meet. So, thank you. Yeah, I'll take a couple of questions. I don't know, Stefan, do I have time to take a couple of questions?
Yeah,
okay.
Just do like 5 minutes.
Okay.
Does Viro work with music?
The question was, does Viro work with Unity? No, it's not. It's not a. So we actually were thinking about doing this project in Unity, and we actually decided that this was a better way to go because so no, Viro does not work with Unity. Unity has its own AR technology that is pretty good. The reason we didn't use a Unity in this project is because Unity still isn't very good at building like just a boring plain app, like with input fields and dealing with keyboard stuff and locales and stuff. It's really good for games, but it's not so good for an actual like app. So it wouldn't be my choice for building something like this. Yes, exactly.
Can you show the GitHub URL again?
Oh yes, sorry.
I will post all this material up later.
Yeah.
Like so the polygon count on like the smaller one, the first example. I noticed like when the turbo squid ones are kind of like more high quality.
Yeah, high quality.
So like, what's kind of the cap on importing something like that into an AR application? Because like, I don't know. Right now, is it possible to do something like use a high quality image and make it a
If you're a graphics design expert and you know how to use Blender properly, you can up the polygon count on the object by basically doing a sort of interpolation, and it will make it look smooth. And you can also add the really shiny effects and stuff. And it really is to do with your skill at the 3D modeling tool, and not so much as a programmer. Because really, as a programmer, you do the same things no matter what you load it in as a file and display it. That's all you do. There's not a lot you can tweak by the time it's called a pre-rendered model. So yeah.
Does it hit performance there? Like when you do that, like is it knows performance in it?
I would imagine if you had a lot of things in your scene, it would hit performance problems. But for just a couple things, it's amazing how much you can do. There's a really cool really cool app that you can download that puts a dragon on the table, and it's amazing. This thing's moving around and roaring, and fire coming out of its mouth and everything. And it's running on your iPhone, and it looks photorealistic. So we'll see if I can find it.
It's mostly about tracking individual objects than it is rendering single objects.
Yeah, exactly. These things, the GPUs in these things are so powerful, and they're so underutilized that it's really capable for these things to do that. It's more about it's typically like in a game, things tend to slow down when there's a lot of entities on the screen, and it's the logic of moving them around in a sensible way that's actually more complicated in the end than the rendering, because the rendering is all offloaded to the GPU. The CPU is when the CPU gets bogged down, it gets slow.
Yeah, I just have another question about the geolocation. Like, did you set it up the tripod and then found that on the app, or did you have to do something to that? I guess I'm just a little confused on how you set that.
I didn't do anything. I just pointed it at the ground, and that's the surface it picked. That was the surface of the tripod. It picked the tripod, so it obviously got something on there and thought it was a surface.
Oh, gotcha.
So that's why it did that. So, but yeah, you don't do anything. So what happens is when the Viro AR component comes up, it starts gathering all these information about all the different surfaces. And there's actually a really cool Apple talk about it. And they'll show you like a visualization. You can see that it's like a cloud of different surfaces that appears. And so what I have to do is pick through and try to figure out which of those surfaces is actually one that would be a good place to put the hat. So I'm kind of looking for certain parameters. And so it happened to pick that one because it was close enough. So. You can, your mileage will vary depending on your algorithm for picking the surface. That's really okay. What you could do, and the easiest way is to get the user to touch the screen, and you can actually shoot a ray through. And there's a Viro component to it. It will tell you like all the surfaces that intersect that, and you can pick one. So that's an easier way to do it. So, yeah.
I remember you mentioned that you sort of set where to look for the surface. For it to go on, so like a meter away and
yes,
like that or something.
Yeah.
Do you know how far out you can go? So if you wanted to make you have a model of a car, right?
Yeah.
You set that to be on the ground 20 feet away, and then walk around that car, get closer to it or something.
I don't know the exact numbers. That's a really good question. The question was how far away can you detect surfaces? And I don't know the answer to that, but certainly up to 20 feet. You mentioned 20 feet away. I've been able to detect. I've actually been able to detect surfaces easily that far out. Like probably even to the back of the room here, you could detect surfaces. It's more about. There isn't actually any limitation. The limitation is the camera resolution, and the cameras are so high resolution that.
I was just thinking as a proof of concept, you could like pull in models of a car, and then just pop the car anywhere, and then you could like walk around it. Well,
that sounds like a great app. I want to see that.
That'd be cool.
Cool. Yeah, I want to see that. That sounds really cool. Yeah, this is the kind of thing I want to see. Like, I'd love to see some really creative ideas. And so again, I think it's all about like this kind of forum is all about sharing code, and so I'll put the examples that I have out there. Not the full source for this thing, but I mean I'll certainly share some samples that would give you enough to get started. But so yeah. All right. Thank you.